Now, we're on to our final question in paper one. And this is, of course, our problem-solving question. In this case, it is a functions and calculus question, but the context of it is to do with financial maths. Now, there's not any financial maths skills in there, but the language behind it is kind of maths and business related. Kinsale Jewellery is a company based in West Cork that produces bespoke jewelry. The cost production function can be modeled by Cx is equal to 0.5x squared plus 50x plus 100, where x is the number of units produced. The revenue, which is income, generated by selling units is given by the function Rx is equal to 80x minus 0.01x squared. Show that the function which represents the profit made by the company can be written as follows. P of x is equal to minus 0.51x squared plus 30x minus 100. Okay, so the language here could scare some students off, but if you take your time to think about this, like how does a company make profit? Well, profit is revenue minus costs. So the profit function is my revenue, which is my 80x minus 0.1x squared minus my cost. So you just got to be careful. Obviously, your cost function here, all the signs are going to change. So it's minus 0.5x squared minus 50x minus 100. Putting that together, you get your profit function minus 0.551x squared plus 30x minus 100. And there's 5 marks for that. So remember, of course, you were given your answer in the question, so it should be relatively straightforward to get there once you think about it. Using calculus, differentiation, integration, determine the production level that maximizes the profit correct to the nearest whole number. So maximum profit occurs where the first derivative equals 0. So here is our function. Our first derivative is minus 1.02x plus 30 equals 0. So here's our first derivative, and we're going to solve it equal to 0. So 102x is equal to 30, x is equal to 29.41, correct to the nearest whole number, x is equal to 29 units. We have to make certain here this is a maximum. Our first derivative was a minus 1.02x plus 30. When I differentiate again, I get minus 1.02. It is less than 0, which implies it's a maximum. Second derivative being negative implies we're dealing with a maximum. And that was 10 marks. Okay. Hence, find the maximum profit. So we have our profit function. We now have our value of x, and it says hence. So that's using the answer we've just gotten. So we're going to put in the 29. And we want to correct it in nearest cent. So it's 341.09, and that's another 5 marks. So hopefully we're going okay. Now this part here, for a student who reads this, again, the language could throw them off, but if you read through it there, it says marginal cost is the additional cost associated with producing one extra unit of an item. Margin revenue is the revenue earned with the production of one extra unit of an item. Using calculus, find the marginal cost and the marginal revenue when x is equal to 20 units. So it's giving you the hint here. Marginal cost is additional cost. An additional cost is it is the change. It's the rate of change of the cost. And so what is it? How do you get it? You get it by differentiating your cost function. So the cost function is here. Using differentiation, you get c dash x, the first derivative is equal to x plus 50. And then when cost is equal to, or when x is 20, so it's for 20 units, you're going to get the marginal cost to be 70 euros. The margin revenue, again, your revenue function is 80x minus 0.01x squared. What is margin revenue? It is the additional revenue earned when producing an extra unit of the item. So R dash x is equal to 80 minus 0.02x. So you put in your 20 and you get 79.60. So those are my two answers for this question. So the marginal cost of marginal revenue when X is equal to 20 units, and that was 10 marks. So the student who stuck with that and thought it out, I would hope would certainly gain the marks for that question. The break-even point, as a concept students in business will be very familiar with, is the point where costs and revenue are equal. Using algebra, calculate the break-even point for Kinsale generally corrected nearest whole number. The break-even points, it says, so there's going to be more than one. So again, we're going to be, with a bit of thinking, this isn't so bad. Cost is equal to revenue. So we get 0.51x squared minus 30x plus 100 equals 0. We can use our minus b formula, and because it says corrected nearest whole number, we would assume that we can't factorize it. The decimal in there, the 0.51, would indicate the same. I get two answers, 3.547 or 55.276. To the nearest whole number, that'd be x is equal to 4 or x is equal to 55. And then the last part of this question, that was 10 marks, by the way. So again, by itself, that's a relatively easy 10 marks and could have been gotten without ever doing any of the other parts because you had these functions from the very start. And on the graph below, plot C of x, R of x, and P of x in the domain. 0 less than or equal to x less than or equal to 60. My students would have heard me say this before. Oftentimes, it can be a good idea to start off, in this case, even with the very last part of the question, and to plot your C of x and R of x at the very start, because it gives you a visual image of it. Now, those of you with the Casio calculators can use mode 3, or the new Sharp can use mode 2 and plot these functions, with steps of 10. Your revenue function looks like that. It looks like a straight line. It's not quite a straight line, but it is in our scale here looks like one. Your cost function is a quadratic, and again, we're only seeing a part of it here, and we can see here then that it does in fact look like that there is a break-even point here at x equals 4, and up here at, I think it was x equals 55 from the previous example. And we can then model our profit, and our profit, when we got our maximum profit, we could say the maximum profit would occur where the gap between cost and revenue was widest, and that was 10 marks. So that brings us to the end of paper 1 and the end of this question. Again, some students would have skipped this because they just would not have liked the language, but those who got stuck into it might have found that it possibly, you could say it was the easiest of all of the context and applications questions. So don't be afraid of these ones that might have a kind of business kind of context to them and language. You just get stuck into them and you'll find they're not so bad. Okay, so now we're ready to move on to paper 2.